Hello, welcome to the second episode of the topic trigonometry. Like I promised you in the last video that this week I'm gonna prepare a topic on the topic special angles. Okay, and the special angle we are going to stress so much today is the special angle of 45 degrees. This angle is special in the sense that it possesses some qualities which some other angles don't possess. Okay, so if you want to figure out or get the special angle of 45 degrees, you can draw a square. So remember, a square is just a quadrilateral or a plane shape having four equal sides. So all the sides of a square are equal in length. Okay, let's assume that here is 1 unit. It means that all the sides will also be 1 unit because a square has four equal sides. Again, another property of a square is that all the angles are equal and the size is 90 degrees. The size is 90 degrees. So all these angles are equivalent to 90 degrees. Now, assuming you get a knife and try to cut this triangle, this square into two, like I've just done, a shape will emanate. Once you do that, you are getting a shape called a triangle, or two triangles will come out. Okay, the first one is this. This is the first triangle, while this is the second triangle. But I'm taking the one below. Okay, so here is 1 unit. Remember, here is still 90 degrees. Here is also 1 unit. But this place, I don't know the value of this size, so I can call it x for the value of this side. But I divided this angle 90 degrees into two equal parts. It means here is 45 degrees. Here will be 45 degrees. Because when you divide 90 into 2, you are getting 45. Also, here will be 45 degrees. And here will be 45 degrees. Okay? So let us attach the angles in the triangle made. So here is 45 degrees. Here will also be 45 degrees. Okay, now this angle and this angle are equal in length, 45 degrees, which is what we are talking about. Any of them can go. If I choose this or choose this, I'm getting the same value because the angles are equal in size. Okay, now assuming this is the angle I am targeting, for instance, it means that here becomes the opposite to this angle. Here is the adjacent, while the longest line is now the hypotenuse. Okay, so here is the hypotenuse. Then from your socatura, remember that sine theta, but our theta is 45 degrees, so I can write sine 45 degrees is opposite over hypotenuse. And our opposite is 1, hypotenuse is x, so I don't know the value of x. This demands that we are going to employ Pythagoras theorem to get this value of x. So from Pythagoras, I can write that x squared equals 1 squared plus 1 squared. Okay, 1 squared is 1, 1 squared is 1. 1 plus 1 is giving us 2. Then I'll take the square root of both sides, which means x is now square root of 2. So x is equal to 2. So I'll write root 2 here as the value of x. Now let's go back again to sine 45 degrees. Okay, so sine 45 degrees is opposite over hypotenuse, and opposite is 1. Hypotenuse is root 2. So it will give us 1 over root 2 as the value of sine 45 degrees. Okay, we still have cos 45 degrees. From socatua is adjacent over hypotenuse, and our adjacent is 1, hypotenuse is 2. It is still 1 over 2. Then tan 45 degrees is still opposite over adjacent. My opposite is 1, my adjacent is 1. So it's going to be 1 over 1. And 1 over 1 is giving us 1. So you've seen the special angle of 45 degrees. Without the use of calculator, we are able to get its value. So wherever you are, get your calculator, press sine 45. It will give you a value, keep it aside. Then use the same calculator to divide 1 by some 2. Compare the two values, you see that they are exactly the same thing, no difference. Again, tan 45 is always 1. One thing you need to picture out here again is that the value of sine 45 degrees and cos 45 degrees are the same, no difference at all. So at this point, let's go into problem solving in 3. Okay, So take a look at problem number 1. We are asked to get the value of x. Okay, x is missing, and we are asked to get its value. So from the first episode of this video, I told you something about the names of the sides of a right angle triangle. This is our angle, and the side facing the angle is known as the opposite. The longest side is known as the hypotenuse, while the third side is known as adjacent. But there is no value in the adjacent, hence the adjacent will not be useful for us in this calculation. So we have items on opposite and the hypotenuse. And when you have opposite and hypotenuse, you now know that you are using the sine, because sine theta, and our theta is 45 degrees. So sine 45 degrees is opposite, which is x, over hypotenuse, which is 26. But we just concluded the special angle of 45 degrees. And wherever you see 45 degrees, you should know that the value of 45 degrees is 1 over sod 2. So I'll use 1 over sod 2 to replace sine 45 degrees, equals x over 26. Now to get the value of x, I've got to cross multiply. And when I do that, I have x sub 2 equals 26 times 1 is still 26. So to get the value of x, I'll divide both sides by sod 2, so that x stays alone. So sod 2 cancels out. I'm having that x is 26 over sod 2. I would have stopped here, but if you are conversant with the knowledge of sod, okay, you know that you've got to rationalize this. Therefore, you can now say that x is now 26 over sod 2 times sod 2 over sod 2. Okay? So x is giving us 26 times sod 2 is 26 sod 2. But sod 2 times sod 2 will give us square root of 4. And square root of 4 is just 2. Okay, but 26 and 2 has a common factor of 2. So we cancel out. Finally, x is equivalent to 13 sod 2. Okay, so let's take another question, number 3. Okay, so I'll take another question. Okay, in number 2, we are given this triangle and we are asked to get the value of the height h. This angle is 30 degrees, here is 60 degrees, and line CD is 15 cm. And we are asked to get the value of h. Now let's first of all consider the bigger triangle. So from triangle ABD, which is the bigger triangle. But before I do that, I forgot something. This BC, we don't know the size, so I can choose to call it X, BC, because we know this CD as 15 cm, okay? So let's call it X, hence, this total length here will be 15 plus X, the total length. So since this one is 15 and here is X, the total length will now be 15 plus X, okay? So if you are considering triangle ABD, the bigger triangle, the angle here is here, so here is the opposite, okay? Then down here is the adjacent, then here is the hypotenuse. But nothing is written on the hypotenuse, so we are working with opposite over adjacent, which is tan. So I can write that tan, remember considering the bigger triangle, 30 degrees is opposite h over adjacent, which is 15 plus x. Okay, so what is the value of tan 30 degrees? Tan 30 degrees is 1 over root 3, so I'll use 1 over root 3 to represent the value of tan 30 degrees, equals h over 15 plus x. Cross multiply. Remember in the first episode I told you why tan 30 degrees is 1 over root 3. Okay, so cross multiply, you have h sod 3 equals 1 times this is still something 15 plus x. Okay, so to make h stay alone, I will divide everything by sod 3. So I have sod 3 here over sod 3. Sod 3 cancels out. I'm having that my h is 15 plus x over sod 3. So I can call this equation 1. Okay, so let's go back to the second triangle. There is a smaller triangle here, which is ABC. So from triangle ABC, we have that the same tan 60 degrees is opposite, which is h, over adjacent, which is just x for the smaller triangle, which is x. Now, but what is the value of tan 60 degrees? Tan 60 degrees is just sub 3. So I'll write sub 3 equals h over x. Sub 3 can be sub 3 over 1. Cross multiply. If I cross multiply, I have that h is equal to x sub 3. So I've got two values for h. This is h and this is h. Remember, I can tag this equation 2. So I will carry this value for h and plug in here in the first equation because that's the value of h. So I will substitute h as x sub 3. So therefore, I can write that x sub 3, which is now the value of this h, equals 15 plus x over sub 3. Okay? This can be over 1. Then I've got to cross multiply. Oh, this is tan 60, right? The value of tan 60 is sub 3, okay, which I've done. But the value of tan 30 degrees is 1 over sub 3. Okay, so we are in order. Then cross multiply. If I cross multiply, I have that 15 plus x is equal to, this time this will give us square root of 9, and square root of 9 is 3. So we are having just 3x, okay? Now, this x will come to the other side. We have 15 equals 3x minus x. And 3x minus x is giving us 2x. So I will divide both sides by 2 to get the value of x. So x is giving me 7.5 as the value of x. But I'm not looking for x, I need to get the value of h because the question said we should get the value of h. But you've known that x is now 7.5. So we can use this equation 2 or equation 1 to get the value of x. But it will be simpler if we use equation 2. So therefore, I can write that h, which is equal to x sub 3, but x is now 7.5 sub 3, okay? So h will now give us, wherever you are, use your calculator to get the value of sub 3, multiply by 7.5. Anything it gives you is the value of x in value of h in centimeter. Okay, so let's take another category of this. I'm going to discuss with you now the complementary property of special angles. So finally, let's conclude with the complementary property of right angles. Now take a look at this right angle triangle. This is a right angle, and of course you know a right angle is an angle of 90 degrees. Now, remember that the sum of angles in every triangle is 180 degrees. And one of these angles has taken 90 degrees. Okay? So out of 180, you now know that 90 is left. But let me say that this angle is, let's say x, and this angle here is y, for instance. You will now observe that x plus y must be 90 degrees because both of them are sharing 90 degrees. Which means x is now 90 degrees minus y. So this place I'm seeing x, I am free to put 90 degrees minus y, or 90 minus y degrees for the value of x here. So I can jettison this x and plug in 90 minus y in degrees. Okay. Now, assuming this is the angle I'm concentrating on, but it now means that here is the opposite to this angle, while here is the adjacent and here is the hypotenuse. Okay? So if I say sine 90 minus y degrees, for instance, I have opposite, which is b, over hypotenuse, which is a. If I say again, cos 90 minus y degrees, you should know that cos theta is adjacent over hypotenuse, and adjacent is c, while hypotenuse is a. Okay. Now if I say again that this angle y should be my center of concentration, here we no longer the adjacent, here becomes the opposite of y, then here becomes the adjacent of y. Okay, so what if I now say sine y degrees is the opposite, which is c over hypotenuse, which is a. If I say cos y, for instance, it will still be adjacent, which is b, over hypotenuse, which is a. Okay, now what are you observing here? You'll find out that this value c over a is the same thing as c over a here, and this value b over a is the same thing as b over a here. So therefore, we can conclude that cos y is equivalent to sine 90 minus y. So therefore, we can write that cos y is equivalent to sine 90 minus y, and again sine y is equivalent to cos 90 minus y. This is an important relationship that exists in triangles like this, in right angle triangles. So we call it complementary property of angles, because complementary angles sum up to 90 degrees. So at this juncture, we come to the end of this episode. Expect the continuation of this episode in our next video. Kindly like and subscribe to my channel for notification. Thank you.
Hey there. Subscribe to my channel. And also press this bell icon.